Alright guys, I'm sorry I'm not here today, but I am going to go through and do these problems with you just as if I were here. So here's a little bit of review from what we did last time in class. On number one, you are solving this equation. First thing that you should notice is that the factors of 16 will not give you 14 in the middle. So the way that you solve this is by what we did last time in class called completing the square. So the first thing that I normally do, just like I told you guys last time in class, is I take the negative 16 over to the other side. Then I take the negative 14x, I look at the number in front of it, and I divide negative 14 by 2, and then I square it. So negative 14 divided by 2 is negative 7. When you square that, you get positive 49. And 49 is what I want to add to both sides. On the right-hand side of the equation, just take out your calculator if you can't do it in your head, but you take negative 16 and positive 49, you add those together, and you should get 33. Then, on the left-hand side of the equation, the reason that we added this 49 to the left-hand side of the equation is to make it be one of those perfect square trinomials like we talked about last time in class. So we know it's going to be a perfect square. What's going to be in this parentheses is going to be x, and then whatever you did when you took the negative 14 divided by 2, that's going to be right here. You should have negative 7. So then you can solve this equation now by taking the square root on both sides. You get x minus 7 equals plus or minus the square root of 33. Then you take the negative 7 and you add it over to the other side. So it makes it positive 7 plus or minus the square root of 33. If you needed a decimal answer for that, you would just take out your calculator and get your decimal answer for that now. Now, in problem number 2, you have under certain weather conditions, the stopping distance of a car is d equals 0.1 s squared plus 1.1 s. If a driver leaves 5 car lengths, which is 75 feet approximately, between him and the car in front of him, how fast should he drive? So what you've been given in the problem is you have been given the distance. And so what you do is you enter in 75 in for your distance. And you are going to solve this equation now for s. So very much like we did last time in class, you want to approach this exactly like the last problem on number 1 that we just did. You want to take it and you want to get rid of this 0.1 first of all. So you want to divide both sides by 0.1 because that will cancel out and give you 1 s squared in the front. Then, if you need some help, you can take out your handy-dandy calculator, divide 75 by 0.1, and then divide 1.1 also by 0.1. Hopefully you wouldn't need to do that one to get it, but just in case. You get 750 over here on the left-hand side of the equation. And then over here on the right side of the equation, you get 11s. So then, just like number 1 that we did just a few moments ago, we want to take this and solve it by completing the square. So we take 11 and we divide it by 2 and we square it. So when we take 11 and we divide it by 2 and we square it, we are going to get 121 over 4. And that is what you are going to add to both sides. Again, if you can't do it in your head, use your calculator. Then you take this side over here on the right and you have your parentheses squared now. In this parentheses, remember, you're going to have whatever you got when you divided 11 by 2, which was 11 over 2, in that parentheses. On the left-hand side of the equation, you can take out your calculator to help you out here. Take it, add 750 plus the 121 over 4. This is not too ugly of a decimal on this one, so if you do want to take it and leave it as a decimal right here, that would be okay on this one because it's 780.25. But make sure that you know how to get your answer as a fraction by doing math, enter on my calculators, just in case you don't have that pretty little decimal like we have in this problem. So it is 3,121 over 4, or 780.25 as a decimal. So then, just like the last problem, we take and we find our square root of both sides. On the right-hand side, that gives me s plus 11 over 2. On the left-hand side, it's going to be a pretty ugly fraction inside that square root, but it's going to be plus or minus that square root. Please do remember, though, you are talking about something in real life here. You're talking about the speed of a car. So make sure that you understand when you go to solve this one, know that your answer should be a positive answer. So, to get s by itself on the last step, you would subtract the 11 halves over to the other side. I'm going to move up here to the top side of this left-hand side over here so we can see it a little better. You take that s equals, and then you have negative 11 over 2, plus or minus the big ugly square root that you see there over 4. And then you take this out in your calculator and you do the math in your calculator. So you take negative 11 halves plus this big ugly square root of 3,121 over 4. Press enter. You get 22.43. You will notice that if you do negative 11 halves minus this square root in your calculator, you will get a negative here. So do not do that one. You don't need it. You're talking about speed of a car. So your approximate miles per hour should be 22.43, or approximately 22 miles per hour is probably what you would answer to somebody if they asked you how fast should you drive. You don't want to drive any faster than that. You want to drive faster than 22.4 miles an hour. You want to drive 22 miles an hour, or probably slower. Obviously, if it's taking you that long to stop in 75 feet under these weather conditions, that means these weather conditions are pretty bad. Okay, for number 3. This was the last thing that we talked about last time in class when we were writing the quadratic function in vertex form. Remember, vertex form looks like this, where you have the parentheses squared. Guys, that's the exact same thing we did back here. That's the exact same thing we did back here, was getting something to be a perfect square like this vertex form. So what you do is basically you attack this pretty much the same way that you attack the other problems. Just like I did on the first one, I subtract the 16 over here to the other side. That gives me x squared plus 6x by itself. Then I take and I want to add something to make this be a perfect square, just like I did on the first one and the second one. So I take the 6 and I divide it by 2, and then I square it. So 6 divided by 2 is 3. 3 squared is 9. So you have 9 on both sides. So you get negative 16 plus 9 over here. That's going to give you negative 7. On the right-hand side, x squared plus 6x plus 9 is that perfect square we were talking about. We made it happen. Remember, it's a process. It's called completing the square. So you get x plus 3 squared, because 6 divided by 2 was what gave you the 3 to square and get the 9. So that's what makes it a perfect square. So then over on the other side, I have y minus 7. The difference here with this one is I'm not going to take this and take the square root like I did on the last problem. Now I'm just trying to rewrite it into this vertex form. So I want to take and I want to add the 7 back over to the right hand side, and I get this x plus 3 squared plus 7. Now it's in vertex form. And if you wanted to find the vertex, if you take the opposite of this one and the same as this one right here, then you get negative 3, positive 7. That would actually be where your vertex is located. Okay, so the next thing I'm going to do is I'm going to go through a couple of the homework problems. I'm going to go through these pretty quickly in rapid succession, so if you need to pause the video, go backwards and rewind it, you guys can do that during class. The substitute can help you do that, or maybe Cole can help you do that because he's pretty good with being a good student. So, Deidre, turn around in your seat. Quit talking to Elizabeth. Elizabeth, quit talking to Caitlin. I know y'all like each other a lot, but make sure that you turn around and pay attention. Make sure you're focusing. Abby, turn off that phone and put your ID badge on. I know you probably don't have it on. Just kidding. But seriously, let's get started. All right, so let's take a look first at number 18. This is a word problem, so I know you guys probably had a question about this. The key with this word problem is understanding that when you're talking about a swimming pool, that is rectangular, you're talking about basically a rectangular prism. And they're expecting you to understand that volume is equal to length times width times height. In the problem, they give you that the depth of the pool is 6 feet, so they're telling you that the height is 6 feet. So you already have that dimension of the pool given to you. So that means you just have to figure out something for the length and the width. So if you look at the top of the pool, that's going to be where your length and width come from. So this is like we're looking down from above. It says one side of the pool is 2.5 times longer than the other. So that means if this side is x, then this other side is going to be 2.5 times x. So you have all you need now. You have the length, you have the width, and you have the height that was originally given to you in the problem. You also have the volume that was given to you. It tells you that the swimming pool is 2,160 cubic feet of water. So you set up your equation by setting 2,160 equal to the length of 2.5x times the width of x times the height or depth of the pool of 6. When you multiply that right-hand side together, you are going to get 6 times 2.5, the numbers multiplied together is 15. And then you have the x times the x, which is going to give me x squared. If you multiply it one at a time, that's fine. 2.5 times 1 is going to be 2.5x squared right here. And then times 6 still gives you 15x squared. All you have to do to solve this one then is divide by 15 on both sides. You will get 144 equals x squared. Take your square root, and then you get x is equal to plus or minus 12. But remember, we are talking about a swimming pool. So you do not want to consider the negative here on this one. All you want to do is know that x is 12. So that means my width for the pool is 12 feet. My height was given to me, it was 6 feet. And then, to find my length, all I have to do is take 12 and multiply it by 2.5, and you're going to get 30 feet for the length of the pool. Number 20 is the next one I'm going to take a look at. On this one's already perfectly set up in a perfect square for you. So all you have to do on this one is recognize the fact that this is going to be x minus 2 squared to get this. You take the square root on both sides. It ends up giving you x minus 2 equals plus or minus 10 because the square root of 100 is 10. Then you add the 2 over to the other side. You're going to get 2 plus or minus 10. 2 plus 10 is 12. 2 minus 10 is negative 8. Whenever you get some nice little answers like this, this means back here at the beginning, you could have subtracted the 100, set it equal to 0, and factored this thing. And probably factoring it might have been a little bit quicker. On number 28, 29, and 30, all they were asking you to do was do the process of completing the square to get what would make this a perfect square trinomial. So all you had to do here was take the 18, divide it by 2, and square it. So 18 divided by 2 is 9. 9 squared is 81. That is a perfect square trinomial. Now, what you would actually do if you're solving the equation is you would then break this down into x plus 9. Remember, 18 divided by 2 was 9. That's what gave me the 81. That's what it's going to split up into as a perfect square. Okay, so the next one we're going to take a look at is number 38. When you look at this one, it's already set up perfectly for you with the 11 on the other side. All you have to do is figure out what to do to make it be a perfect square. So you take 8 divided by 2 is 4. 4 squared is 16. So that's what I add to both sides. When I do that, on the left-hand side, that gives me x plus 4 squared. Remember, the 8 divided by 2 gives me the 4. 11 plus 16 on the other side over here is going to be 27. So when I take my square root on both sides, I get x plus 4 equals plus or minus the square root of 27. 27 can be split up though. Remember, 27 is also 9 times 3, dummy. So 9 times 3, when you take the square root of 9, you get 3. You leave the other 3 on the inside. And then to get this plus 4 off the left-hand side of the equation, you subtract 4. And so you're going to get negative 4 plus or minus 3 on the square root of 3. Again, if you need a decimal answer, you can take out your calculator. Okay, so on number 44, there's really two ways that you could have approached this one. So I'm going to show you the way that we talked about in class last time. The first way is to take that 2 and subtract it over like we talked about with the other ones, but you still realize you got the 9 in front of the x squared. So I told you you could divide both sides by 9, leaving you with x squared minus 4/3 x equals negative 2 over 9, or negative 2/9. Then you can do the exact same thing that we've done on the other problems. Add a perfect square here to both sides to make it work, make it be a perfect square trinomial. So you would have to divide the 4/3 by 2. That's going to give you 2/3. When you square that, you're going to get 4/9 is what I should add to both sides. So on the left-hand side, that's going to give me x minus 2/3 squared. On the right-hand side, negative 2/9 plus 4/9 is 2/9. When you take the square root of both sides, you get x minus 2/3 plus or minus the square root of 2 over 3. The square root of 9 is 3 on the bottom. Then you add the 2/3 over, and so that will be 2/3 plus or minus the square root of 2 over 3. Sorry about that. Another way that you could have done this is you could have taken this at the very beginning of here. And some of you might recognize the fact that if I move the 2 over and make it negative 2 over here, I could add something to both sides that will make this be a perfect square already. I could take it and I could add 4 right here, because that would make the left-hand side be 3x minus 2 squared. Some of you might recognize that, some of you might not. On the right-hand side, if I add 4 as well, that will give me a positive 2 on the right-hand side. When I take the square root of both sides, that will give me 3x minus 2 equals plus or minus the square root of 2. If you add 2, you're going to get 2 plus or minus the square root of 2. But you still have the 3 in front of the x, so when you divide by 3, you will see that you get 2 plus or minus the square root of 2 over 3, which is the same thing that we got a second ago. They were just kind of split up when we did it by completing the square over here in this normal fashion. Number 49, you were writing this one in vertex form. So to do this one quickly, you add the 7 over, so you get plus 7 over here, x squared plus 4x. If you want to take this and write it in a vertex form, you got to add something to make it a perfect square, so you add it to both sides. 4 divided by 2 is going to be 2. When you square that, you get positive 4 that you add to both sides. So you're going to have y plus 11 on the left. You're going to have x plus 2 squared on the right. To get it in the vertex form, you just subtract the 11 over, and that's going to give me x plus 2 squared minus 11 on the other side. Okay, so probably the most interesting problem out of the ones I gave you for homework was the example of the football punted. So you see that the kicker's foot contacts the ball, and the height is measured by h. The x is the horizontal distance after the kicker kicks the ball. So, in this problem, it asks you to put it into vertex form to find the maximum height of the punt. So if you want to find the maximum height of the punt, then getting this into vertex form is one of those ways to do it. Another way to do it is what we did originally at the beginning of the chapter, which is doing the opposite of b over 2 times a, plugging it in for x and finding the height. Remember, you can find the vertex in another way. But for sake of practice, we're going to do this one the way it looks. So first thing you need to do is, like we talked about on the previous couple problems that we looked at, when you have a number in front of the x squared, you need to divide that negative 0.1 or 0.1, excuse me, out of all of them. When you do that, you are going to have h over negative 0.01. We're going to talk about that. That guy's going to affect us here in a little bit. We're not going to mess with him right now. When you divide it out here, you're going to get x squared. You're going to get negative 118x. And then you're going to get negative 200 over there for the c. So then you take this, and just like I showed you on the other ones, I add the 200 over to the other side. So I add 200 over to the left. On the right-hand side, I'm going to have x squared minus 118x. And I'm going to add something now to make those be a perfect square. Again, you take the 118, you divide it by 2 and square it. When you take 118 divided by 2, you're going to get 59. When you square that, you're going to get 3,481. Beautiful, huh? Same thing on the other side. You're going to get 3,481. And so then, on the left-hand side of this equation, you are going to have a positive 3,681. On the right-hand side, it's going to break down to x minus 59 squared. How do I know that? Remember, 118 divided by 2 is the negative 59 here. So then, what I would want to do is to get h by itself again. So basically, I'm just going to reverse kind of some of the stuff I did earlier. I'm going to take this and subtract the 3,681. This is going to give me x minus 59 squared minus the 3,681. But then I want to get rid of the negative 0.01 on the bottom, so I'm going to multiply this whole equation. That means the left-hand side and the right-hand side by negative 0.01. That's going to cancel out and give me just h on the left. It's going to give me negative 0.01 times this x minus 59 squared here. Guys, think about this. That's that a value in front of the parentheses. That's telling you that your parabola is opening down. And the 0.01 is what's making that parabola stretch out a little bit and be a little bit wider than it normally is. Or compressed, I should say. Sorry, I used the wrong word. Then you multiply that 0.01 times that 3,681. When you do that, you're going to get 36.81. Because it's a negative times a negative, that's going to be positive 36.81. So what you see there then is now your vertex is staring you in the face. 59, when you take the opposite of this one, and 36.81, when you take the same as this one, is going to be my vertex. So what is the height that the ball got to, the maximum height? It is right here. 36.81 feet is the maximum height that the ball got to. Part B says the nearest defensive player is 5 feet horizontally from the point of impact. How high must the player reach to block the punt? So if he's 5 foot horizontally, all you have to do is plug in 5 for x squared, and that will tell you how high the ball is at that point. So you take out your calculator and you do negative 0.01 multiplied by 5 squared plus the 1.18 times 5 plus the 2, and you get 7.65. So how high does the guy need to jump to block the punt? Well, his hands have to be at least 7.65 feet in the air. Part C says, suppose the ball was not blocked but continued on its path. How far down the field would the ball go before it hit the ground? So what you would have to figure out here is 0 for your height. And so what you would do is you would go through this process of completing the square with 0 here in for your height. So, let's take a look at that. So this is part C. And so you take 0, plug it in for your height. You'll have negative 0.01 x squared plus 1.18x plus 2. You solve this using the techniques that we've done before. Again, you're going to have to divide that negative 0.01 out. And so what you're going to end up with here is 0 x squared plus minus 118x minus 200. So when you add the 200 over to the other side, you're going to get x squared minus 118x. The good news is you've already done the hard work here. You've already divided the 118 by 2 and squared it. So you know you're going to take and you're going to add 3,481 to the left, and you're going to add 3,481 to the right. The difference now is you're going to, now once you get this x minus 59 squared, you are going to take the square root to find the solution here. You are not just going to try to find the function in vertex form. So you get x minus 59 plus or minus this big square root of this ugly number. You add the 59 over, so it's going to be positive 59 plus or minus that square root of 3,681. So I take out my calculator, I do 59 plus the square root of 3,681, and I get 119.67 feet. So approximately 119.7 feet would be probably a good approximation. One decimal place would be okay there. If you subtracted this, you would notice that if you subtracted this 59 minus this square root of 3,681, you're going to get negative 1.67. The reason that that is a negative number is you've got to think, when the punter kicks the ball, he's going to be kicking it from a height that it's already starting at as the beginning amount, and then it's going to go this way. So the x-intercept back here of negative 1 is going to be as if that parabola continued. Remember though, he's kicking the ball from a starting height where it lands is 119.7 feet. Okay, so now we're going to take a look at the quiz. I graded these and I saw a lot of the same common mistakes with everybody, so I'm going to try to point out those major mistakes that I saw with a lot of people. I'll explain why things were graded the way they were as much as possible, but probably not going to be on every single question very, very, very detailed. So make sure that you're paying attention to how I went through and solved the problems. That'll help you out. This will help you review for your test, because basically your test includes everything that's on this quiz, the things that we did last time in class when we dealt with the completing the square, the imaginary numbers, and the quadratic formula, which we're going to talk about here in just a little bit. So, first of all, going through the first couple here, these were 1 point apiece. First one is standard form. Second one is intercept form. And the third one is vertex form. Remember, the vertex form calls at the vertex out to you pretty quickly. You can see it if you do opposite and same. Standard form, that's the one where you got to use the opposite of b over 2a to find your vertex. Intercept form is much like the factoring that we did, and you have to get it factored into those factors to get your intercepts and then find halfway between where your vertex is. The symbol is called a radical. It is not a square root symbol. I know that's what you normally do, what it tells you to do with it, but that is not what the symbol is called. The graph of a quadratic function is called a parabola, not a parabola, not the virus, not a virus like Ebola, but a parabola. The maximum or minimum point is called the vertex. So, let's take a look at the next section here. The next section is involving graphing. I'm not going to go through the entire process of graphing. I'm going to hit the main points here that most people missed. First of all, most people on this first one, if you forgot this little formula of negative b over 2a, that was really going to get you. If you didn't do that formula correctly, that was really going to get you, because it was going to keep you from being able to find the middle of your table of values. So you should have had the opposite of 2 over 2 times 1. Your b value is 2, your a value is 1. Remember, ax squared plus bx plus c. That will give you negative 2 divided by 2, which is negative 1. That should be the number that goes into the middle of your table of values. Guys, it's the middle point on the graph. It's the middle of your table of values. Then you just count down negative 2 and negative 3, count up 0 and 1 for your x values, and plug them into your function. This was the second biggest area of mistake that I saw. Plugging in numbers into a function, you have to make sure that you use parentheses around the x's that you plug in. Guys, I showed you this middle column on this table, plugging in these parentheses and then hitting the squared key, plugging in the parentheses beside the 2, and then having the plus 5. Having it written out in this middle of this table helps you out, helps you kind of plan out what you type into your calculator. When you do this one, you should get 8 here, 5 here, 4, 5, and 8. And I'm not going to plot the points. If you don't know how to plot points by now, then we're in more trouble than we are going to be able to fix with just me going over a couple problems off the quiz. So, 8, 5, 4, 5, and 8. Guys, notice the pattern. This is another thing that messes some people up. If you mess up this middle number right here, you can notice it when you start plugging in values and you see some really, really big or really, really small values. That means you probably don't have the correct middle value. The middle value here should be the lowest or the highest point. We just talked about that on those one-word definitions at the top. The vertex is the maximum or the minimum point. So, same kind of concept when you get to number 8. When you get to number 8, you are taking this one, finding the vertex. The difference with this one is you just have to remember this is vertex form. So you do the opposite and same. So when you do opposite of -3, you get +3. Same as -1, you get -1. So when you plug in, make your table of values, you're going to put 3, -1 in the middle of your table. Then you're going to plug in 2 and 1. You're going to plug in 4 and 5, which are numbers that are bigger and smaller than 3. When you do that, you should get 7 here, 1 here, 1 here, and 7 here. This one's stretched out a little bit. Notice the 2 in the front of the parentheses. That tells you that this graph is stretched out a little bit, so it should be a little bit skinnier than the other ones that you encountered. Again, same kind of mistakes that I saw on this one, I saw on number 7. People forgetting to find that middle point or forgetting how to find that middle point. And so some people lost some points there. If you see -8 points, that means you did not get any credit. That means you were way off base, completely off base. So make sure that you go back and practice those graphs if you got -8. So number 9. Number 9, when you look at this guy, it says solve the equation. Guys, the only way that you knew how to solve the equation when you took this quiz was to go through and factor this guy. So to factor this, you would take it and you would say x and x is a +6. So I look in the middle, that tells me both my signs are going to be minus. Guys, listen, I know that the factors of 6, 1 and 6 will give you 5 if you put a plus and a minus. But that will not give you +6. It has to be the same signs, and they both have to be negative to get the 5 in the middle. So you should get a -2 and a -3, factors of 6 that give me 5. Then you don't stop here. When you are solving an equation, you take x minus 2 and set it equal to 0. Take x minus 3, set it equal to 0, and you get 2 and +3. Remember, these are the same things as my x-intercepts, but they're also the solutions to this equation that make it equal 0. So, if you messed up on the factoring, I probably subtracted 2 points. If you got the factoring done, but you didn't set them equal to 0, I probably only subtracted 1 point, because these solving equations shouldn't be too bad of equations to solve, so I gave you a lot of credit for doing the factoring correctly. On number 10, you had to get this one set equal to 0 first. So you would have had to add the 4r squared to get 9r squared. And then you have 12r. Then you subtract, you add 4 over and you get +4 equals 0. So now you have 9r squared plus 12r plus 4 equal to 0. So when you have that, then you take this and you factor it. And this one should be one of those special patterns, 3r plus 2 squared. When you set 3r plus 2 equal to 0, you subtract 2 and you divide by 3 and you will get -2/3. And there's only one answer on this one because the fact that both factors would be the same factor. On number 11, I know a lot of you are wondering why you lost some points, because I did tell you I was giving you some bonus there. Guys, remember, I also told you that you should know how to start solving that equation. You should know how to solve some basic parts of that equation. I didn't expect you to go through and solve it completely, because that was part of the bonus, was the final answer. But you should have been able to realize that this is x squared plus 121. You can subtract the 121 and get -121, and take the square root of both sides and get x equals plus or minus, and then you might have had the oh no moment here where you said, I don't know what to do here. This is where I expected you to get to. So if you didn't get to at least here, or at least try to get the square root of -121 and maybe write something down with a plus or minus, then you lost maybe a point. If you lost 2 points, that means you left it blank. Said, I don't get it, I don't know how to do it. Guys, you know how to solve by finding square roots. We've been doing that even before we talked about imaginary numbers, which is what this actually will give you, which is a 11i on both sides. Okay? And I don't know why I said both sides there, but 11i is your answer for that one, plus or minus. So, 12, 13, and 14, we're just going through and factoring. You will probably, some of you, be really mad at me here because you didn't pay attention to what I told you in class. I told you anytime you can divide something out of them, you should do that first. So on this one, you should divide a 5 out of both of these first and get x squared minus 9. Then you can split that up into x plus 3 and x minus 3. Same thing on number 13. You can divide 3 out of all three of these. You get x squared minus 4x minus 5. If you do not divide the 5 out, if you do not divide the 3 out, you have not factored. Factoring means taking and dividing out that number first and then seeing if you could split up the rest of this. So on this one, you should be able to split this up into x plus 1 and x minus 5. The factors of 5 that give me negative 4 in the middle. The last one, you could not divide anything out of all three of these. And so this was the one where you had to really think about it. You had to think of the factors of 18, which would be 1 and 18, 2 and 9, 3 and 6. You had to think of the factors of 14, 1 and 14, 2 and 7, and make sure that you get them into the right spots. Notice that this is negative 14, so I am going to have a plus and a minus. And then I know that I'm going to have a positive 9 in the middle. So what I did was I started off with using 7 here and 2 here because I figured whatever I had right here and whatever goes in this spot is going to be multiplied by 7. It's probably going to be a bigger positive number, so I'm looking for that positive 9 there. So what you end up seeing is that this does work. If you put 6x here and 3x here, because 6x times negative 2 is negative 12. 7 times 3 is positive 21. 21 and negative 12 is going to give me positive 9 in the middle. Guys, I think I even told you before you took this one, I said, if I give you one to factor on this quiz, I'm probably not going to tell you to factor it if it doesn't factor. And still, some of you wrote the words cannot be factored. Guys, I even told you that it probably would be able to factor. Number 15. On number 15, this is where people started to really fall apart. Guys, I gave you a little formula for this. I said the area of the big minus the area of the small equals the area of the border. When you're talking about one of these border problems, that's a border around an object such as a frame, a picture frame, a swimming pool with concrete around it, whatever it may be. Okay? So on this one, when you set this guy up, you're going to have the area of the big shape is going to be a length times a width. The area of the small shape is going to be a length times a width. And the area of the border is going to be something that is usually given to you, sometimes not. And so that's why I left this off for just a second. So in this case, the big shape includes the 3, and it also includes the x and the x. Remember the beginning amount and what you change it by. You're adding 2 x's to this beginning amount of 3. Same thing for the width. This is a square, so this is not a rectangle. You're going to have a square here. You're going to have the same thing for the length and the width. Then the small shape is just the inside, the clear glass top of the coffee table. So you have 3 times 3 for that one. So what you end up here with is when you multiply this out, you're going to get 9 plus 6x plus another 6x plus 4x squared minus 9 when you take away the small. So right here, when you subtract all this out, you're going to get 4x squared plus 12x. The 9's disappear. Guys, the small area is subtracting. Remember, it goes away. This right here is what I told you that is the area of the border. That is the little formula for the area of the border. So what you're trying to figure out in this problem is when does this equal 7? Because that's how much square feet of cherry you have to make the border. Okay? So you take this and you solve it much like we did those last couple problems when we looked at the solving by factoring. You subtract 7, set it equal to 0. This factors into 2x plus 7 and 2x minus 1. And so one of your answers is going to be negative 7 halves I know I'm going quick through this, and positive 1/2. Guys, your answer is going to be 1/2 foot, or 6 inches, or half a foot, whatever. So, when you look at that one, guys, make sure that you understand that beginning amount and what it changes by. That's a key to understanding a lot of quadratics that we do. It'll be a key to that revenue problem that we're going to look at here in just a moment. Big problem here on this one is some people just leaving it blank. Some people getting parts of this equation, but not all of it. Some people plugging in the wrong numbers in the wrong spots. But I tried my best to give you as much partial credit as I could. But I can tell you right now, if you didn't show me something like you knew what you were doing, you probably lost a lot of points. This one was worth several points. 10 points total, I believe, is what the total amount was. Number 16, this one was worth about 6 points. This one here has a right triangle for your figure. So you should immediately be thinking something along the lines of a squared plus b squared equals c squared. You can claim to me that we never did this in class. We did do one in class. You can claim you were absent on the day we did that one in class, but that does not negate the fact that you have done the Pythagorean theorem before. The tricky part about this one that messed most people up is when you plug in your a squared, you're going to have 4x squared. When you plug in your b, you're going to have 3x squared. And you plug in your c, you're going to have 35 squared. You have to square the whole thing. So this is actually 16x squared plus 9x squared equals 1,225. Most people mess it up by having a 4 and a 3 right here. But you probably only lost 1 point if you solved everything else correctly after that. Now, if you messed up some more stuff, you might have lost more than 1 point. 16 and 9 is going to give me 25x squared. I divide both sides by 25, and that gives me 49. I take my square root, and x is equal to plus or minus 7. But, since we are talking about distance, it's okay if you put 7. So x is equal to 7. If you want to find the distance that the kids would travel if they didn't cut across, then you plug in 7. You do 4 times 7, plus the 3 times the 7 on the bottom, and you get 49 feet. Several people, I don't remember if it was your class or not, but several people tried to tell me that they traveled the same distance. Guys, there's no way that's possible if you are traveling in a right triangle or you're traveling across the hypotenuse of a right triangle. Number 17, down at the bottom here. This one you were finding a quadratic model using the 3 points. You do not know if one of these points is the vertex. So you cannot use vertex form to help you go through and set these up. You have to set these up using that ax squared plus bx plus c. So what you end up doing is you end up plugging in 15 for y and then negative 2 for x. So you get this for the first one. You plug in 1 for y and then you plug in 0 for the x. Guys, you're plugging it in for the x, so make sure you do just like you do in a table of values. You literally plug it in where the x is. So whatever's happening to the x, which is being squared right here, is going to happen to the x that you're plugging in. When you do that, you should notice on the first one up here, you'll get 15 equals 4a minus 2b plus c. You're going to get 1 equals c. And then you're going to get 1 equals 4a plus 2b plus c. So what you can do on this one, because of the easiness that I gave you here, c is 1. You already know your answer for c. Then you can plug that value in here and use that to help you find your a and your b. I'm not going to go through this because we've been through a 3-variable system several times. But your a value ends up being positive 7 over 4. Your b value ends up being negative 7 halves. And your c value you already see here is 1. So your equation should be 7 fourths x squared minus 7 halves x plus 1. That would be the equation that passes through all 3 of those points. Alright, so last page shouldn't have been too bad. On the last page here, you were just going through and you were making sure that you do a couple of quick things on finding this one here. The equation of this one is in vertex form. So your vertex here is at 3, 2. So you're going to have y equals x minus 3 squared plus 2. So you've already got that set up. You just need to find what the a value is that goes in front of that. And so what you do is you plug in another point. I probably would have chosen the 0.44. And so if you plug in 4 for x and 4 for y, and you solve this to find your a value, you will see here that you get a times 1 when you square that, which is going to be a plus 2 equals 4. If you subtract 2, you're going to get 2 equals a. So your equation should have a 2 right here in the front of there. On the other part, this one actually should have been one of the easier questions on the test, but some of you really tried to overthink this guy. I give you the equation. It's in standard form. So if you want to find the maximum height, you find the vertex using negative b over 2a like you did on the graph for number 7. So you take the opposite of 1 over 2 times this negative 0.0032, that's my a value, and you will get 156.25. When you do that, that is the x value of the vertex. You plug it into your function for the d here, and so you take it and you find the maximum height, which is going to be 81.125 feet once you find the height by plugging in 156.25. How far is the baseball from home plate? That's what 156.25 is. That is the horizontal distance from home plate. That's what D represents. Then the last question, if there's a 16-foot tall fence that is 300 feet from home plate, did the batter hit a home run? All you have to do, 300 feet from home plate, means you plug that 300 in for the distance for D. It'll tell you what the height is. You'll get 15 feet. So what does that mean? If there's a 16-foot tall fence, that means that the ball would hit the fence instead of going over the fence. So it would not be a home run. The last question, I gave you credit for setting this guy up because we didn't get to spend a lot of time going through and solving this one using the calculator. So I gave you some credit for setting this guy up as long as you set up the equation. And I think I gave bonus credit maybe to somebody who actually did find the correct x-intercept. This one is exactly like number 15, where you were finding the area of the table. You do the same thing. This one is using a swimming pool. And so it's 25 foot by 10 foot, so you're going to have 25 plus something and 10 plus something for your length and your width, minus 25 times 10, the area of the small, equals the area of the border. Now this is where I try to trick you a little bit. It's 304 cubic feet of cement, but it says the walkway will be 1 foot thick, so that means it's 304 square feet that you actually use for the cement. Tried to trick you a little bit there. Some of you got it, some of you didn't. You're going to add the same distance all the way around, so it's going to be 2 x's that you add to the length, and it's going to be 2 x's that you add to the width. So when you multiply this guy out, you're going to get 4x squared. You're going to have 25 times 2, that's 50. 10 times 2 is 20, so you're going to have 70x. And then the 25 times the 10 is going to be 250, but it's going to cancel out with this 250. So you're finding when the area of the border equals 304, just like we did on the other one. And so if you got to here, I think I gave you credit. And if you subtract the 304, I also gave you credit because you're setting it equals 0 trying to factor it, but you can't factor this. Any questions there can be answered next time in class. That is what you would have needed to write on your quiz to make a 100. So we will look at that a little bit more if you ever have any questions. So the one thing I want to say here is to tie into what we've been looking at last class and what you're going to be looking at today for the rest of class is that now you can use something that I showed you at the end of class last time called the quadratic formula. To solve this equation, you can actually use something that we looked at last time. Last time in class, at the end of class, I showed you how to find something called the quadratic formula. And the quadratic formula is a way to find, I do have my notes here, sorry. A quadratic formula is a way to find an answer for ax squared plus bx plus c, no matter what a is, no matter what b is, no matter what c is. You can go through and find the answers to that equation. Even if it doesn't factor, even if it doesn't complete the square very easily, you can find the answer if you can find the a, the b, and the c. And the solutions of this equation are equal to this. And this is what the formula looks like. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. This formula, if you use the b and the a and the c from your equation, will give you the answers for x. Notice the plus or minus tells you you're going to have 2 answers unless the stuff that is inside this square root is 0. If there is a 0 in here, you're only going to have 1 answer. And it's going to be a real answer. So that is why in your book you will see the inside of this formula called the discriminant. Because it will tell you what kind of answers and how many answers you will have. If there's a number inside that square root that is negative, you will have 2 imaginary answers. If that number inside the square root is positive, you will have 2 real answers. And if it is 0, you will have 1 real answer. So, let me kind of summarize that for you a little bit. If b squared minus 4ac, which in your book is called the discriminant, don't worry about that word, I'm not going to ask you to spell that or anything. If b squared minus 4ac is equal to 0, there is 1 real answer. If b squared minus 4ac is negative, that means less than 0, there is 2 imaginary answers. If b squared minus 4ac is greater than 0, or in other words, if it's positive, there is 2 real answers. So this equation, this little formula, will give you the answer no matter how ugly your equation gets. So even that one that we just looked at, if you're looking at that example off the quiz, number 20, your equation for that one was 4x squared minus 70x, plus 70x minus 304 equal to 0. A is 4, B is 70, and C is negative 304. You can use the quadratic formula to solve this equation. Okay? So this is a pretty ugly formula. So what I usually do is I tell people to remember Pop Goes the Weasel. I know that's weird, but there's a song that you can sing to remember this. And basically the song goes like this. You sing it like Pop Goes the Weasel. So, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. I really wish I could see your faces right now because I bet you are dying laughing. I know, that's hilarious. But I guarantee you, if you will go through and you will remember this formula using that song, you'll be sitting on the test, and if you forget it, start singing that song, and all of a sudden it'll start to pop back in your head. I have students who come back to me years later and tell me, I remember the stupid quadratic formula because I hear your stupid voice singing the song. So, let's do it one more time. How about you sing with me this time? X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Beautiful, huh? Maybe I should take a career in something that, no, I think I'll keep teaching. So, you use this formula, you plug it in. So when you take a look at this guy right here, you're going to have x equals negative b. B is 70, right? Plus or minus square root of b squared minus 4ac all over 2a. Isn't that beautiful? But you take the a, the b, and the c, and you plug them into this formula, and you do the math. So you're going to need your calculator. Okay, I even use my calculator here. But make sure you don't try to type this entire thing into the calculator. I can guarantee you, maybe one of you out of the entire class, probably Cole, will be able to type this thing into the calculator and get the answer the first time. So most of you, almost all of you, and maybe even Cole, will forget one of the parentheses. So you can take the calculator and do everything that's inside that square root. That'll help. So you can take that calculator and you can say, okay, 70 squared minus 4 times A, which is 4, right, times C, which is negative 304. And you can type all that in and take the square root of that. In just a moment, we're going to look at that. Let me back up just a second. And you're going to take the square root of that to find what is going to be added to the negative 70 and subtracted from the negative 70 divided by 8. There are two answers to this. Negative 70 plus that square root over 8, and then negative 70 minus that square root over 8. Now, since this one was talking about a real life problem, we do not want the negative answer. Be careful though, these can kind of trick you every once in a while which one is actually the negative answer. So be careful, don't assume that you know which one's going to be the negative answer. So, take out your calculator and do it. Negative 70 plus the square root of 9,764. Press enter. Divide the whole thing by 8. Notice that I didn't divide it by 8 here because if I didn't put parentheses around my negative 70 and my square root, it's going to give me the wrong answer. So this is 3.601. So this in the real life problem is actually what you're going to have for your concrete, cement, that's going to go around your swimming pool. It would be that wide. The other one, you can still get the answer for it, even though it's not going to help me in the real life situation. I take negative 70 minus the square root of 9,764. And I don't know why that thing is not going to take the square root for me. Let's try that again. There we go. When you press enter there, you divide that number by 8 as well, and you get negative 21.102, or just negative 21.1 is fine, but approximately negative 21.102 is your other x value. This will be one of your x-intercepts, and this will be the other one if you graph this equation. But remember, we only wanted the positive on this one because we were talking about going through and finding the length or the width, of my walkway. Okay? All right, so that's the quadratic formula. That's how it works. You go through and you plug in the numbers for A and B and C, and you find the answer. Notice that, like I said, if the number inside the radical is positive, you're going to have 2 real answers. If it's negative, you're going to have 2 imaginary answers. And if it's 0, you're going to have 1 real answer. And guys, think about it. It should make sense. If this is 0 inside here, it's going to cancel out the entire square root here. And so it's going to be negative b over 2a, which is the vertex. That means that will be the only point that crosses the x-axis. That's why you would only have 1 answer if all of this stuff ended up being 0. All right, I'm going to do a couple more quick problems for you on the quadratic formula. This one, first thing you need to do is take the 35 and subtract 35 over to the other side. Get it equal to 0. Then you do your formula. So, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So, you take negative times 8 plus or minus the square root. 8 squared minus 4 times 3 times negative 35. All of that over 2 times 3. And so you're going to get negative 8 plus or minus. On the bottom you're going to get 6. And inside the square root you're going to have 8 squared minus 4 times 3 times negative 35. When you do that, you're going to get 484. When you take the square root of that, that's going to be 22. This one actually ends up being a nice perfect square. You know what that means? That means you could have factored this guy and probably saved a lot of time. I know, bad time to find out now, right? So negative 8 plus 22 is going to be positive 14 over 6, which reduces to 7 over 3. And then negative 8 minus 22 is negative 30 over 6. Negative 30 divided by 6 is negative 5. Save some time on this, and I went ahead and set it equal to 0 for you. When you do the opposite of b plus or minus the square root, b squared minus 4 times a times c, all over 2 times a, you're going to get 6 plus or minus 2 on the bottom. On the square root, you're going to have 6 squared, that's going to be 36, minus 36 over here, 4 times 1 times 9. That's 0. What did I tell you about that? You're going to have one answer when that happens, because the square root of 0 is 0. 6 plus 0 is going to be 6 over 2, which is 3. 6 minus 0 is going to be 6 over 2, which is 3. That means your vertex is the only place where this one would hit the x-axis. Again, on this one, I went ahead and set it equal to 0 for you. Notice that it doesn't matter if your a is negative in this one. As long as you plug in the right parts of the formula, you will be able to get the answer. So when you plug in your b here in those two spots, plug in your a as negative 1, plug in your c as negative 2, you're still going to get the right answer out of this no matter what. You don't have to have that be a positive x squared. So you get negative 2 here, you get negative 2 on the bottom, plus or minus. Inside the square root, you're going to end up with 4 minus 8 over here, which is going to give me negative 4. What does that mean? That means it's going to be negative 2 plus or minus 2i over negative 2. If you divide both of those by negative 2, yes, you can divide a plus or minus by negative 2. It's not going to switch the symbol because both symbols are there. So you just take negative 2 divided by negative 2, you get 1. This plus or minus still is going to be a plus or minus when you divide it, and you get I. We'll talk about that a little bit more next time if you have any questions. So, here's your homework. Make sure you go home and practice that. Page 237 was the one you did the other day that was going to the complete and square process. Page 245 is the quadratic formula page. I told you both of these were going to be due on Friday, so make sure you take a look. Go back at 237 if you need to look through it again. Look at 245, that's the quadratic formula. Go through and get those answered. Make sure you come ready with questions. See you next time.